So we want to prove the theorem vertex of the parabola. Of course, this is the theorem for the quadratic equation, which we have up here. And what we're trying to prove is that the coordinate of the vertex h, k, well, that can be found by saying minus b over 2a, that's the x coordinate, and minus d over 4a, well, that's the y coordinate. Now, down here we have a sketch of the parabola. Here we have, of course, the parabola right here, which is a quadratic function. And then we have the point down here, right, the vertex called h, k. Now, we've drawn in 2 points on this parabola. The first one is x0, c. Now, if this point is on the graph, well, then we know the equation f of x is equal to ax0 squared plus bx0 plus c. If we look at the other point, well, that's 0, c. As we proved previously, this is their y-intercept, and for this it counts that f of x is just equal to y. Or not f of x is equal to y, f of x is equal to c, of course. So one other thing that we know is that we want to, of course, prove what h and k are. If we start with h, well, then if we look at the graph down here, we can tell that h, of course, is the line right here, x is equal to h, goes right here. Over here we have the line that's x equal to x0. Now, the distance from the y-axis to here is twice as, or like is half the length to out here, meaning that it counts that h is simply x0 over 2. Now that we know this, we can start with the proof. So, over here we're going to have to ignore the part of f of x over here. We're not going to use that for the calculations. So we just write ax0 squared plus bx0 plus c is equal to c. Now, since we know that if we know x0, well, we can find out what h is. So we want to isolate x0. We do this by subtracting c on both sides, meaning that they cancel out. So we're left with ax0 squared plus bx0. And of course, c minus c on this side, well, that's just going to be 0. Now, since we have two terms that equal, first of all, we look at the two terms over here, and we see that they both have x0 in them. That means that we can factor them. So we do this by, of course, putting x0, the least common factor, outside of parentheses. So we do this x0, and that will be equal to ax0 plus b. Now, after we factored this, we now have two terms that are multiplied with each other that equal 0, and that means we can apply the 0 rule. And of course, we do that by saying the first term equal to 0, x0 equal to 0, or the second term, let's see, which is over here, x0 plus b is equal to 0. Now, over here we can't really do much. We've already isolated x0. Over here, though, we have to isolate x0. So we do this by taking this part of the equation right here and isolating x0. And of course, we do this by subtracting b first on both sides. So we get that ax0 is equal to negative b, and then we divide by a. So we divide by a on both sides. Yep. And basically, let me do this in a different way. So when we divide by a, we of course get that these two cancel out. So minus b over a. So we get that x0 is equal to minus b over a. Now, it's of course h that we want to find, not just x0. So we take the h over here. H is equal to x0 over 2. Now, of course, we just now substitute in our new value for x0, which was minus b over a. So we have minus b over a over 2. And then we apply the fraction rule that dividing a fraction, if we have a fraction in the numerator and we just have a whole number or an integer in the denominator, well, that just means that we can multiply these two and leave the numerator as the top one right here. So it will be the same as minus b over 2. And then we've isolated h. We now know that h is equal to minus b over 2a. And that's the same thing as we have over here. Okay, so for the next part, now that we've found h, well, we basically know the domain and we need to find the range. So the range k, well, that can therefore just be found by taking f of h. Now, if we take f of h, we essentially just take the quadratic function up here, but instead of taking f of x, as we do here, we just take f of h. And since we know that h is equal to minus b over 2a, well, we insert that instead of the x from over here. So it's going to be a times minus b over 2a plus squared, of course, and then b times minus b over 2a and then plus c. Okay, so from here we basically just need to do basic algebra on the right side of the equation. So first we'll work with this first term right here. We can reduce that by using a fraction rule, writing a times minus b squared over 2a squared. And then the rest is just the same for now. So plus b times minus b over 2a plus c. We just reduce the first term even further. So if we go down here, well, multiplying an integer with the fraction, we just multiply it up in the numerator. So it's the same as a times b squared over 2a squared, and the rest is just the same. So plus b times minus b over 2a plus c. Now over here, we can apply a power rule. It says that if two terms in parentheses is raised to the same power, well, then we can just take each term to that power. So it will be a times b squared still, and then we have 2 squared, and then times a squared, and the rest is the same again. So we have b plus c now, and plus c. So now we have over here 2 squared, which is just 4, and then we have a squared here and a up here. That means we can cancel out one of the a's. So we end up with b squared over 4, because 2 squared is 4, and 4a plus b. And the b right now, actually, we just do the same as we did for the a. We multiply the b up in the numerator of the fraction. So we get plus minus b over 2a. Or b squared, of course, because we multiply the b with a b, so we get b squared, and then we have plus c. Now we're getting closer to solving it, because we now have a similar denominator in the two fractions. So c, we can actually do that right now, make that into a fraction. And if we need to make c into a fraction, well, it's just going to be c over 1. So now we can get a common denominator, and that will be 4a. So we have to multiply these two fractions, or we have to extend these fractions in order to make them have the same denominator. So the first one, we just leave it as it is. Yes. And that will just be b squared over 4a plus. And then of course this fraction we need to extend with 2, because 2 times 2 is 4, and then a is just a, so we need to extend it by 2. So we need to multiply both the numerator and the denominator with 2. So we get plus and then minus 2b squared, and then here we will then have 4a. And then at last, well, the c, in order to get 4a down here, we need to multiply by 4a. So we're going to get 4ac on the top. And then over 4a. We have 4ac over 4a. Now, since that they have the same denominator, we can apply the fraction rule, and that allows us to make them into one fraction with that denominator. So we're going to do that. We have b squared, and then we have minus 2b squared, minus 2b squared, and then we have plus 4ac, and everything is over the denominator, which is 4a. Now we can cancel out, well, we have b squared here, but we have minus 2b squared, so we cancel out 1b squared, and we get just minus b squared, plus 4ac over 4a. And we can reduce this further, because we know from previously that the denominator, we found that in quadratic equations, and the denominator d is equal to b squared minus 4ac. Now, it's the same thing that we have down here, except that the signs are reversed. We have minus b instead of positive b, and we have positive 4ac instead of minus 4ac, which means that we have negative d down here. So we're going to write negative d is over 4a. And this is the last part that we needed, because now we found, up here we started with k, and we ended with minus d over 4a, which is what we wanted over here. And now we have that h and k, we found them to be the coordinates over here, and proven.
Hey,